If you're watching this, it's probably because you're about to take some kind of exam and you're wondering if there's anything you can do to help beyond the obvious. What do you do apart from practicing lots of questions? I want to talk to you a bit about exam technique and how this can help you to develop into a better problem solver, as well as helping you to get the best you can out of an exam. Up to a certain point, increased stress levels can improve your performance because they raise your concentration levels and they give you heightened cognitive skills. However, it doesn't continue indefinitely. If you get too much stress, it decreases your performance because your higher order thinking processes shut down a little bit in favor of the more primal fight or flight response. What this ends up looking like is an increased heart rate, increased sweat production, and brief but frightening bouts of a total inability to do basic algebra. So, given that you're likely to be in a stressful situation when you're taking an assessment, especially if it really matters to you, how should you prepare? Well, the first thing I would recommend is to not look down on the value of fluency. I like to say we don't rise to the occasion, we sink to the level of our training. When the military and the fire service drill a procedure, they do it over and over again so that they can perform it automatically, even when they're under pressure. It doesn't matter whether they're under extreme stress, whether they're in the line of fire at the time, they do what they do because they've always done it. And if you've ever said, well, yes, I'm laying out my work in this shoddy way right now, but I'll do it properly in the exam, or yes, I'm just looking at the answer in the back right now, but in the proper exam, I'll do it differently. Chances are you're going to do what you've always done when you get to the exam. Especially in times of stress, you fall back on old habits. So what you want to get in the habit of early is doing the things that you want to be able to do in the exam. Nobody's going to be shooting at you while you're sitting your exam. No one's going to bleed out if you drop a minus sign. So it's not going to be quite like being in the army or being in an operating theatre. And therefore, you shouldn't reduce your entire revision schedule to mindless repetition of mathematical techniques that you've mastered long ago. But there is certainly a place for a level of fluency with the basic skills so that those don't slow you down and hold you back when you're doing other things. In pure maths, this is going to include things like manipulating indices, square roots, reciprocals, working with quadratics, being comfortable solving them, sketching them, quadratic inequalities, using the discriminant with or without a calculator. Sometimes you'll have numbers, sometimes you'll have additional variables to deal with. So make sure you're comfortable with all of those. Make sure you know what you're doing with straight lines, using the standard equation like y minus y1 equals mx minus x1 when you're trying to find the equation of a line through a point with a given gradient. Things like that can make your working more efficient, and they can reduce the number of different steps you have to hold in your head at any one time. Basic differentiation is always a good thing to have developed fluency with. You don't want to be stopping and thinking about how to differentiate sine 3x. It needs to be just there at the tip of your fingers. Otherwise, you'll be concentrating on the details instead of the big picture when you're in a tricky question. When it comes to applied maths, we're thinking about the basic statistics, understanding without having to think or look it up what is meant by a mean or a median and how the interquartile range is similar to but not the same as the standard deviation. Working with probabilities, the basic ways of combining them, the key rules and how they work, how you interpret common diagrams, histograms, Venn diagrams, tree diagrams, and then routine procedures, what you do when you're dealing with a probability that x is less than or equal to 7 when it's a binomial distribution, or how you deal with a probability that x is more than 5 for a normal distribution. If you are setting up and solving Suvat equations for a mechanics problem, think about how you can automate a lot of that process. Practice so that you have a routine that you follow. S, U, V, A, T, fill in the ones you know. As soon as there's 3 values that you have, you can find either of the other 2, etc. So that's fluency. The next thing is to make a plan. This is why I have a prop. The thing you want to be thinking of here is at the beginning of an exam, spend some time going through the questions, looking at each one. If you spend 10 minutes sharpening the axe, you're going to save perhaps an hour chopping down the tree. Okay, so my rather clunky prop that's going to make a great thumbnail. If you've got an axe that's not particularly sharp, it's not going to do you much good. And you can rush ahead and say, well, this job needs doing, so I'm going to crack on. But you're not going to get very far if your axe is blunt as this. So you spend a little bit of time preparing, and it might be that in the first 10 minutes you get less done than someone else. But in the remaining hour and 30 minutes or the remaining hour and 50 minutes or whatever you have left, that time is going to be more effectively spent and you should end up with getting a lot more done. If you have 10 minutes of enforced reading time at the start of your exam, then this is also a good thing for you. It means that you have to read the questions instead of thinking in terms of exactly what you need to do right now for question 1, part AI. You have to glance at the question. Maybe you spend half a minute or a minute just looking at the first question, and then you just move on and look at the next one. Look at the surface features. Glance at a question, recognize that this one's something to do with a curve that crosses the axis here, and they're asking you about a normal line. Maybe think about the kind of techniques that might be useful for it. Read through a little bit more detail for the more detailed questions and see how part C relates to part B. Maybe notice that there's a trig question where the first bit asks you to prove an identity and the second bit asks you to solve an equation that just happens to look a little bit like the identity that you already proved in the first part. Notice the things where you might not be able to do part A because you might struggle on a proof, but you can do part B because you're able to use the result that would have been proven in the first part. It might feel counterintuitive, but a little bit of time at the beginning can really pay off in the long run.